Today's lecture is all about agriculture and sustainable agriculture. So by the end of the class, you guys should be able to define sustainable agriculture, describe the benefits and problems with sustainability of current agricultural practices, and provide several methods for improving agricultural sustainability. And remember, when we talk about sustainability, in this case, we're looking at socio-ecological systems. So sustainability should be able, especially when we talk about sustainable agriculture, that should be agriculture that does not impede the environment to the extent where future generations cannot enjoy the environment. It does not use economic practices that generate an awful lot of profit now, but hinder the ability of people in the future to meet their economic needs. And also, it should not have impacts on society today that reduces the quality of life for society in the future. And in many cases, there are examples of agriculture that have actually managed this. So this is the sort of high up in the Intermountain West. This is often used as grazing land. While that does have a lot of impacts, it has been taking place relatively sustainably. It's not had no impact at all, but relatively sustainably for a couple of hundred years. You then look at agricultural systems in Europe. This is an image of a Swiss village. I've personally visited places in Switzerland where the same families have been farming in the same area for, in some cases, the last 600 years. That is, I would argue, relatively sustainable. They're often still using the same practices they did years and years and years ago. The difference is now that the majority of their income doesn't necessarily come from the farm itself in terms of livestock production, but it comes from essentially people who want to visit and stay and sleep in these little farms and experience, the rural Swiss lifestyle. But those are great examples of a farming practice that's taken place for hundreds of years that has not had any real changing effect on the environment during that time. The family has been able to sustain itself economically, and socially the village still operates in much the same way as it always did. Okay, so this is possible and has been done around the world. Just one thing to think about before we get started. I understand that Logan and Cache Valley generally is a pretty agricultural area, so I just thought it'd be worth having this thought about your own personal farming background and your background in relation to agriculture. If you fancy it, then please feel free to email me your answer and exactly where you sit in this and a bit of your background. So as a fake clicker question, I would say my background in relation to agriculture: A, I am from an urban area and my immediate family is not involved in ag. B, my family gets some, but less than 50% of their income from ag. C, my family gets more than 50% of income from ag, but do not own the farm, i.e. are employees. D, my family are agricultural owners, more than 50% of the income. We farm livestock. E, my family are agricultural owners, more than 50% of income, and we farm crops. So if you're interested, just send me an email about your own background. And thought we'd start with this idea about agricultural systems around the world and also historically. So historically, through time, this is what the vast amount of agriculture has looked like. So if we're going back, bearing in mind we started farming, there is some debate on this topic, but somewhere between 5,000 and 10,000 years ago, humans as a society started farming. For the vast majority of that time, and in many parts of the world to this day, that farming looked a lot like this. So this is individual people, manual labour used to plant and tend to the crops. So it was very labour intensive. Every farm required a lot of employees. Those employees were required to do an awful lot of work by hand. Nowadays, especially in the West, much of our farming looks more like this picture down here, where rather than lots of employees and lots of people working on the farm, we have very few people actually working on the farm, but it's very heavily mechanised. So now machinery is doing most of the labour. So for those with an agricultural background, this is a tractor. Behind it is a hay bob tedder. That is essentially mixing the hay around in order that it can dry better and actually be harvested as better hay. Hay has to be dry when you harvest it, or it doesn't really work, it just rots. But historically, this job would be performed by a gang of about 12 or so people with pitchforks, literally flicking the hay over and keeping it moving around so that it dries. Nowadays, over here in Utah and the US generally, and especially in Europe, this job is performed by a person on a tractor. And nowadays, an awful lot of farms in a lot of Europe look a lot more like this. This is what an agricultural system looks like. So, does anybody recognise this area? Anyone at all? Well, in a way, I hope you don't, because this is actually my farm. This is where I grew up, just here. This is a place called Tegsnose Farm in the UK. At this point, when I lived here, we eventually moved to a secondary farm, which we'll talk about later on, but we farmed predominantly sheep, like these ones at the front. And this is what agricultural systems in northern England tend to look like. So you have the main farm, and the area is privately owned. It's not a ranching system like it is over here, and it is very heavily fenced. So you can see these black lines are dry stone walls. I learned how to build these when I was a kid. It is insanely labour intensive, but they literally last for hundreds of years. And the farmland is divided into different fields. Sheep of different ages, different breeds are raised in there, privately owned. What you do notice about this area is it's relatively free of trees. There's a few scattered around. Historically, sort of pre-agriculture, this whole area would have been covered in mature oak trees. But farming in the UK and Europe generally has led to massive deforestation, conversion of oak forests into grasslands, and that's what our farm looks like now. But the farm in which I grew up in, Tegsnose, the main house is about 400 years old. It's operated the same way for its entire history. So that's what agricultural systems look like. Historically, very labour intensive. Nowadays, especially in the West, very machine intensive. In many cases in Europe, established for a very long time, but they've led to huge deforestation. Now, I'd just like to take a minute for you to think about. We talked about and we drew some concept maps early in this class, especially with relation to things like genes and chromosomes and organs and organisms. I'd now like you to take literally just a minute to put together a concept map where we're looking at farms, crops, livestock, employment, local community, markets, crop pests and crop pest predators, water and soil. I'm going to give you about a minute just to draw what that concept map should look like, and then we'll compare it to the one I came up with. Okay, start from now. Okay, you guys are just over half the time. $10 left. 5, 4, 3, 2, stop. Righty, see what you came up with compared to what I did. So this is how I would draw this concept map. I've also color-coded mine just for ease. So in my concept map, the blue is sort of people and the stuff that's directly involved with the farm itself. Green is the broader human community. Orange is the broader sort of ecological community. So if we look this through, so we've got our farm in the centre. Our farm provides livestock, it provides crops, and it provides employment. For the farm to operate, it requires water from the ecosystem and it requires soil from the ecosystem, but it's also it requires crop pest predators, because these crop pest predators will help remove crop pests. In addition, the farm, what you farm on it and how well it succeeds and how much investment you put into it is affected by the market. So, for example, in years where, let's say, corn is heavily desirable, an arable or crop farm will plant a lot more corn than it will soybeans, for example. The market directly affects the local community. The local community is also directly affected by water, but it just shows you this whole schematic a little bit about how a farm itself and the things it produces are integrally linked with the local community around it in terms of humans and also ecosystems more generally. So this is a very basic concept map. And a farm generally should have 4 basic goals. This is why we have them. First of all, they provide goods in terms of food, fuel, fibre and biofuel. Food in terms of crops and livestock, fuel in terms of things like biofuel, biodiesel, but also in many cases forests and forestry is considered almost a form of agriculture, especially in British Columbia. That produces fuel for wood and things like that. Fibre in terms of cotton, hemp, things like that. Biofuel in terms of bioethanol and biodiesel. In addition, a farm should also maintain environmental quality. In many parts of the world, farmers actually consider themselves custodians of the landscape, and you'll have farmers who are very proud about some of the animals that live on their farm and the general state of the environment. Farms should also provide economic vitality. They need to provide jobs. They provide jobs for the farmers themselves, and also they often provide jobs for local community and people that work in markets and general other aspects of the food delivery system. Farms also provide a quality of life. The amount of hours that you have to put in to actually maintain a farm is incredibly high. It's far higher than it is for many other jobs. And you also, in many cases, actually live at your work. The concept of working from home is a bit strange to a farmer because their farm is their home and also their business. Despite these incredibly long hours and difficult and stressful lifestyle, the reason that many people actually stay on as farmers is because they just enjoy the quality of life. They like being outside all the time. They like working with their hands. They like tilling the soil and maintaining the ecosystem. As a result, if you speak to many farmers, they'll be very clear about the fact that if, for example, they went into a city and got a job doing something else, they'd probably get higher pay and be less stressed. But there's something about the quality of life of living on a farm that's very appealing to a lot of people. We did a very basic concept map. This is a slightly more extreme concept map. That's the living farm. This is based out of South Africa. The Cape Floristic region in South Africa is a huge farming area. It's one of the reasons why the area is so populous. It's very lush and wet, and so it's excellent farming location. But they are, it being Africa, very aware of the interactions between agriculture and biodiversity. So an awful lot of the literature that's put out for sort of landscape of living farms in Africa has a lot of talk about maintaining the biodiversity, making sure the water is kept clean, safe and not polluted, making sure that the soil is not excessively degraded so that farming can continue, but also so the ecosystem itself remains healthy. Also, farmers tend to be very aware of natural cycles, especially the carbon cycle and the nitrogen cycle. They have to learn this because it's critical to their business, but they're also aware of how it affects the ecosystems around them. So this is a slightly more complicated concept map. If you want to have a look at where farming sits in broader society in the food delivery system, then we have this concept map. I would never expect you to know all of this, but this is a concept map of the global food delivery system, and it includes everything from security, science, which is covered by politics and governments and geopolitical relationships. Politics and governance goes into the global, national, regional, and local scale. We have funding and fees, regulations, subsidies. Here is the actual basic inputs for farming itself. Then it goes through the processing. This is the production. Then it goes into consumers. We've got all these value chains and everything else going around. I don't want you to learn all of this. All I want you to know is that the global food system is incredibly complicated, and the production of all that food is predominantly from farms, but it's embedded in this much bigger web of things that are going on. Okay, so if we look at the current status of agriculture, and we touched on this a little bit, but over in the West, agriculture tends to be very large scale. So it uses hundreds, in some cases hundreds of thousands of acres. It tends to be very heavily mechanized. Nowadays, the vast majority of labor that takes place on a farm is done by machines. Historically, it was actual manual labor, so the people, and also draft animals like horse and oxen. Nowadays, it is heavily mechanized. Any farm you see will have multiple pieces of equipment on board, working there, each one of which is retailing at, in the tens of thousands of dollars. They are huge, mechanized, industrialized machines. Also, the vast majority of farms nowadays rely heavily on off-farm subsidies. What we mean by off-farm subsidies is things like fertilizer, pesticides and herbicides. These are chemicals and other products that are taken from locations outside of the farm, brought into the farm and used to increase production. Because adding, for example, fertilizer in some cases is made out of fish meal from fish that are harvested out of the ocean. That is nutrients taken out of the ocean, brought onto the land, placed on a farm and then spread across the farm so that the crops that you're growing have more nutrients on which to survive. Same with pesticides. These are off-farm chemicals. People aren't producing pesticides on the farm itself, and then they're brought in, and then that increases production. This is what we mean by off-farm subsidies. Things being brought in from outside in order to increase production on the farm. And what these off-farm subsidies and mechanisation has allowed us to do is have quite significant agricultural improvements over the years in the US and in Europe as well. So first of all, we'll look at this graph here. On the x-axis we have time. On the y-axis we have percent. And we're looking at the share of disposable personal income spent on food in the United States between 1960 and 2016. And what we see generally is over the years, we now spend less of our total disposable income on food. This is because food has become proportionally cheaper overall. So what it means is we don't need to spend as much money in order to obtain as much food. One thing that's interesting is that the actual amount of money we spend on food at home, as supermarket runs, is going down. This is not because we're necessarily buying less food, but just because that food is becoming proportionally cheaper. If we look at the food away from home, there's been a slight increase in eating out, but it's remained relatively stable. The big change has come in this food at home. Our mechanised agriculture and our use of off-farm subsidies has allowed production to go up, and that has reduced the cost of many agricultural products. One of the things that really brings this home is if you speak to your parents and grandparents and you talk to them about the availability of steak. If you talk to my parents, bearing in mind my parents were in their 70s, it was pretty much impossible to get hold of steak when they were growing up in the 60s. The reason for this is just because it was so expensive. The only people that really were able to get hold of steak were the one percenters that passed even the upper middle class, and it's because food production was incredibly expensive. Nowadays, most families will have steak once, if not twice a week. It's not that and the quality of it is much higher. This is not because we as a society have necessarily earned an awful lot more money all of a sudden. It's just because mechanised farming, reductions in labour and use of off-farm subsidies have driven the cost of farming down. Also, if we look at the value of agricultural exports, this is from the US, this is US exports of consumer-orientated agricultural products in billions of dollars. Again, we've got time on the x-axis and value on the y. We see that in the US, we've had this large increase in the amount of agricultural products that the US exports to other nations. And this is not universal across the board. We can see that our biggest increases have been to a large increase in almost a tripling of the amount of agricultural exports we send to Canada. We have, this is the rest of the world, this big bar here. So the amount of stuff that we export to the rest of the world has increased by about a factor of 4 since the year 2000. And also, the amount that we send to other nations has increased a fair bit as well, especially Mexico. So the US, despite the fact it is a highly developed Western nation, is still exporting large amounts of agricultural products to other nations. This is actually counter to what we see in the rest of the world, and what we've seen historically, because normally you tend to have agricultural products being exported from developing nations into developed nations. Developing nations tend to have a lot more focus on agriculture in terms of their major industries, and these agricultural products get sent into developed nations. This is, for example, where we get the terms like a banana republic, which was a sort of classic old term for nations that are producing large amounts of agricultural products. The name banana suggests some tropical locations, and the main part of their industry is just exporting tropical fruits to the rest of the world. The US is kind of interesting in that because of its increased reliance on mechanization and off-farm subsidies, lowering prices, it's actually economically viable for the US to be exporting food to other nations. If we also have a look at agricultural improvements in terms of output, we can see that this increased mechanization and off-farm subsidies has allowed agricultural output to increase with no real change in total farm inputs. So this on here is a graph of US agricultural output, inputs and total factor productivity. Again, we have time on the x-axis, and here is the y-axis. When we're talking about the index, we're saying 1948 we're taking as 1. So this was the amount of agricultural productivity that was taking place in 1948. That's our starting point, and we're looking at how, over time, all these different parameters have changed in relation to 1948. And what we can see in the comparison, first of all, let's look at inputs. In comparison to 1948, yes, we have seen some increase in agricultural inputs. There was a big boom in the sort of 70s and 80s. This is as we started to get the hang of industrialized farming, but we then managed to make it far more efficient. And we can see that actually the total farm inputs haven't really changed that much since way back in 1948. But then if you look at the productivity and the agricultural output, that has increased markedly. So even though we're not really adding that much in, changes in efficiency have allowed us to get an awful lot more out. So our farms, although they're not taking out much more input, they're becoming much more efficient. One of the ways you can really see that is in terms of energy use per unit of farm output, which is this graph here. Again, we have time on the x-axis, and now we have energy use based against 1948. Energy use per unit of farm output, and we can see that the amount of energy we use per unit of farm output has dropped by 2008 to basically half of what it was in 1948. So in the space of 60 years, we've made our farms so much more efficient, they're producing essentially twice as much for every unit of energy going in. Now let's think about what some of these what the causes of some of these agricultural improvements are. Well, there's a few things. For one, land used for grazing has increased between 2002 and 2012. So here on the x-axis, we have time again. The y-axis, we have millions of acres. We can see that here's our grassland, pasture and range. This has ticked along generally pretty well, and there's been a big uptick in 2002-2012. We're using much more grassland, pasture and range now. This is due to society's increased demand for beef. However, we look at the grazed forest land, that's actually decreased markedly. And so this grazed forest land is areas where sort of some sections of open range, but it's forested instead. There's been a move away from grazing in there. And also cropland and pasture mix, that's dropped down an awful lot as well. So that shows you how land use has changed, but it doesn't really tell us about the increased productivity. Increased productivity can be seen in this figure here. This one is focused mainly on grain yield, but the same thing can be applied to livestock farming, because a lot of livestock farming is now based on grain rather than grass-fed. Here we have time on the x-axis. Here we have grain yield on the y-axis. This is number of kilos of grain produced per hectare. Start in 1965. What happened was, in 1965, they changed the genetics through selective breeding of grain, so we went from double X to single X hybrids. This managed to make them grow an awful lot faster. During this period, we had an expansion of irrigation in farmland generally, and increased use of nitrogen fertilizer. This made the land both more productive because A, it was wetter, and B, it had more nutrients. During this section, this was combined with conservation tillage, so that's ways that you till the soil so that it doesn't damage it too badly, and it means the soil can be used continuously. And also we moved from just pure nitrogen fertilizer to NPK fertilizer. That's nitrogen, phosphorus, and potassium fertilizer. Then also this was combined with integrated pest management, is when this section started. That is, integrated pest management means you're not only using chemicals to control pests, but you're also using things like biological control. One of the big examples of this is using ladybugs to control aphid pests in an awful lot of greenhouse systems. That works incredibly well. And combining this biological control with chemical pesticides means you can dramatically reduce the amount of pests. So this, so far, all of these have led to increased amount of grain yield per hectare. Then there was a big change. So in the mid-90s, we started to use genetic engineering and started making transgenic or genetically modified crops. One of the big things we were able to do in this genetically modified crops was actually genetically modify crops so that the crop itself produced a form of pesticide. What this meant was you now had crops that were insect resistant. That massively reduced the impact of pests and reduced the need for pesticide. As a consequence, productivity was able to go up, and during this time they also got far more efficient with the use of fertilizer and irrigation. Nowadays we're using computer simulations and things like that to know exactly when to water and how much. Same with nitrogen. That has led to increased productivity. So over time we've had this linear increase in the amount of grain we can produce per hectare, and it's due to all of these different things taking place. Okay. One of the other things that's happened is that the type of farms that we see on the landscape has changed. So the reason for that change is due to changes in profit margin. So this figure here, hope it's coming through okay, tells you the profit margin based on different types of farms. What we see is on the x-axis we've got starting with farms that are very small, so farms that do less than $1,000 of business a year, going all the way up to farms that do business of more than $5 million a year. What you see generally is that small farms do not make a profit. They make massive losses. These are your hobby farms. These are people that are got a few crops going in the backyard. They might be raising a few chickens, maybe goat milk and things like that. Little hobby farms, they are not profitable at all. You don't really get profitable until your farm is so big it's doing more than $250,000 of business a year. And over that course, farms become much more profitable. By the time you're getting up to the $5 million a year farms, these are the gigantic industrialized factory farms. The profit margin is actually becoming quite big. What that means is agricultural improvement, this increased efficiency, has really been felt on the gigantic farms. In order to really gain the benefits of being more efficient, of having mechanized equipment and subsidies, you have to be a big enough farm in order to acquire it. If at the same time we look at what's happened in terms of the percentage of US farms present on the landscape, going from 1997 to 2000, 2007, we see that yes, there's been a small increase in the number of giant farms. These are the big industrialized ones, the black line. The middle-sized farms have gone down. This is because they're just not profitable. This is this group here. So as a result, they've been sold on, and often they get taken over by a large industrial farm. But we also saw a little bit of an increase in the hobby farms, farms that are doing less than $10,000 a year in business. So this is the number, the absolute number of these different farms and landscape. But if you look at the percentage of US farm sales, this is the amount of products that are produced and sold from different types of farm. We see that all of the middle-sized farms and even the hobby farms, the percentage of farm sales has gone down, but the percentage of our goods that comes from these massive industrialized farms has gone up dramatically. So, it all sounds like good news. We've managed to make massive amounts more production from every unit of habitat. The reason for that has been the increased industrialization. It's making things more profitable, brilliant. However, it is not without consequences. And one of the really big consequences of a transition to an industrialized farm is soil loss. You might have heard about things like the Dust Bowl, which is when there was a large water shortage in the Midwest. As a result, lots of the topsoil literally blew away and the entire Midwest became unfertile and all the people moved over to California. That is happening on a small scale the whole time with most types of industrialized crop farming, because they do lead to large amounts of soil loss, because after harvesting the soil is left bare. And if you look at the annual soil loss in terms of tons per hectare by different crops and technologies in the United States, some of it is really, really high. And especially when we're looking at, if you look at corn, conventional continuous, conventional plow and disc, conventional continuous, the amounts of soil, topsoil being lost is really quite high. Soybeans, again, conventional soybeans, if you do any sort of tilling, either conventional or rotation, you're losing large amounts of topsoil. The only way to reduce it is to no-till. That's the same as you get in corn. The problem with using no-till agriculture, it massively reduces your efficiency. If you then look at cotton, see cotton, conventional cotton farming leads to the highest amount of topsoil loss of any farming type. It does drop an awful lot if you don't till. Same with wheat and just natural vegetation, undisturbed grass. Think of this as a control. This is the amount of topsoil you're losing through just natural vegetation. Compare these numbers to these numbers. That is 3 orders of magnitude. You're using that's about 100 times more soil getting lost using this conventional agriculture compared to undisturbed natural systems. Okay, when you're looking at cotton, conventional cotton leads to 1,000 times more topsoil getting lost than if you were just to use natural vegetation. So it can be bad. This is what it looks like as an illustration. This is an illustration of about 500 milliliters of topsoil blown from cropland in Kansas during the winter of 1995-1996. What happens there is they harvest in the fall, and then the fields are just left fallow during the winter. During that winter, the big high winds that go through the plains end up ripping the topsoil off. This is the base of what they were planting before. It looks like wheat. That was the stalk going up there. And you can see this was the base, so all of this would have been underground. This is the root system going down. So all of this, the ground level would have been here. All of this topsoil has been lost. And you can see the scale of it with this Swiss Army knife here. So it is very dramatic, and this loss of topsoil is really bad. It generates dust in the atmosphere. That leads to pollution in lakes and rivers. It can actually affect your lungs, and it means the landscape itself is being massively degraded. Also, one of the things that we see from agricultural improvement, especially the use of off-farm subsidies, we talked about this last time, excessive fertilizer going into agricultural landscapes, making its way into the rivers, leads to these oceanic dead zones. So we talked about this last time, but here is the Mississippi watershed. This is a huge agricultural area. All of the fertilizer that runs off this landscape goes into these rivers, goes downstream, and ends up making its way into the Gulf of Mexico. When it gets there, it leads to big, massive algal blooms. These algal blooms lead to huge drops in oxygen, creating these oceanic dead zones. This is the size of it here, as we showed last time. So the use of fertilizer has allowed agricultural systems to become much more productive and much more efficient, but it is leading to huge problems with these dead zones. One of the other consequences of increased agricultural production has been emissions. Everybody has talked about, we've talked a lot about carbon dioxide, CO2 emissions. One of the other big greenhouse gases that we produce as people is methane. We don't produce as much methane as we do CO2, but methane is a much more powerful greenhouse gas than CO2 is. And if we look at where methane comes from in the US, well, about 33%, about a third of it comes from natural gas and petroleum systems. The production of natural gas, the burning of natural gas and petroleum generates methane that goes out into the atmosphere. Then we have other, just our basic everything else. Manure management, this is literally taking care of cow and sheep turds, generates about 8% of the methane that exists that we emit. Coal mining produces an awful lot because it releases natural gas. Landfills, the breakdown of the rubbish, especially organic food, scraps and things like that, that generates about 20% of the methane that we as people produce. But a huge amount, 22%, is what we call enteric fermentation. This is a euphemism for farts. This is the amount of methane that is produced by farts coming out of livestock. I've given this sort of illustration of an embarrassed looking sheep having a little toot, but 22% of one of the biggest polluting greenhouse gases we produce comes out of sheep and cow farts. So if you look at the total amount of methane that's being produced in farming, you take this enteric fermentation and manure management, we're producing about as much methane out of farming as we're producing out of natural gas and petroleum systems. If we also look at nitrous oxide emissions by source, and nitrous oxide is really bad because that's now the biggest contributor of acid rain, the vast majority of nitrous oxide now comes from agricultural soil management. This is off-gassing of fertilizers and things like that. So the vast majority of nitrous oxide, which is a pretty nasty pollutant, is generated by the management of agricultural soils. So, although industrialized farming, increased mechanization has allowed us to become much more efficient, it's not without consequences, and it does generate big emissions. One of the other things that's happened due to change in agricultural improvements is increased fragmentation of the landscape. So, let's go back to this figure here. On the x-axis again we have time, and here is the percentage of US farm sales. We see that, yeah, sales from medium-sized and small farms have dropped, whereas sales from large farms have increased an awful lot. The issue with that is, in large farms, they tend to be massive, gigantic areas, and to make machinery use more efficient, they don't have any forest on that farm. They just convert the entire area to sort of arable and pasture. What that means is the percentage of conservation area on large farms is much lower than it is on small farms. So if you look at the percentage conservation areas, this is area on a farm that's just left as natural, so little bits of forest and grassland and things like that. So on farms that generate on average less than $500,000, anything up to 70% of that farmland will actually be forest and natural areas. Or it'll be grassland that's left conserved and untouched for longer so that it helps natural ecosystems. On large farms, it tends to be less than 10% of the farm area is left for conservation. This is because leaving this area as conservation reduces efficiency for machinery use. What that means is we end up with landscapes that look a bit like this picture on the left, whereas this is a heavily mechanized, industrialized farming landscape, and you can see that the natural areas are highly fragmented. They're just little sections. Little patches of natural landscape are left dotted around all over the place. There is no big, continuous forested area, which is necessary for an awful lot of natural ecosystems to function. So one of the things that's happened by this move to industrialized mechanized farming is an increase in what we call habitat fragmentation, which is not good. Some of the other consequences have been changes in terms of social and economic, changes in what we actually produce. So if we look at the percentage of farms raising different commodities, this is in terms of livestock. In the US, about just under 40% of all livestock farms are raising beef cows. Second in the US is horses. An awful lot of places are actually horse farms and stud farms. Then we have sheep and goats, much, much lower, poultry, and then hogs and pigs. If we have a look at percentage farms raising different commodities, not just, not of livestock, but instead of arable products, we see that we've got an awful lot of forage crops. These forage crops are crops that are being made on one farm purely to be fed to livestock on another farm. So the largest proportion of crops that we produce is not things like cereals that we then eat ourselves. It's actually grains that are used, or forage food that's used to feed farm animals on other farms. Okay. Then we have grains and oilseeds. Then we go down to corn. Then we have soybeans. And then we go to corn silage. One of the things that's crucial about these, just in the same way this is not a food crop for people, this is not really a food crop for many things. In often cases, this is used for, both of these are used for the production of biofuels, and corn silage is what we use to make high fructose corn syrup. So as a result, the vast majority of actual arable crops we produce are not necessarily for human consumption. One of the other things that we've seen as we improve agriculture has been pesticide problems. So over the years, the increased efficiency, especially of many forms of production such as fruit production, has led to an awful lot more pesticides being used. So on this x-axis we have time, and then for the different colours are different areas of the world. What we can see is that, okay, Middle East and Africa hasn't really increased its pesticide use that much. The reason for this is because they never really have. A lot of their farming is not nearly as industrialized as it is in the West. Here's us in the US. Between 2000 and 2012, our pesticide use increased a bit, but not an awful lot. If you look at other places, Europe has increased its pesticide use a lot because they've had to. Europe is a bit short on space, so it's had to make it a lot more efficient. Asia has gone through a big period of industrialization, and its pesticide use has gone up a lot. But the real big climb has actually been in Latin America. So Latin America, the amount of pesticide they use has more than doubled in the space of just over 10 years. The reason for this is because Latin America has become a major fruit producer in the recent years, and fruit production, especially things like orchards, it's very difficult to make like transgenic orchards like we've been able to do with our food crops. As a result, they have to rely an awful lot more on pesticides than other parts of the world. And what that's led to is an awful lot of incidences of farm worker pesticide illnesses. This is just reported in California, but you look at the number of illnesses that have been reported, and also what's tough is some of the actual breakdown. So, if we look at the vast majority of people reporting illnesses, it is Hispanic men. This is because an awful lot of the people that are working on these crop and agricultural lands are often seasonal labourers. There'll be people that have come in short term from Latin America. An awful lot of Hispanic men. So 85% of the people that reported to hospital with pesticide illnesses were Hispanic, and 80% of those were men. If you look at the pesticide illness by category, it's everything from organophosphates all the way around to pyrethroids. All of these are nasty chemicals. Look at the actual systems, parts of the body affected. Just under half were dermatological. This is skin reactions because pesticides have come in contact with your skin. Pretty terrifyingly, an awful lot of it is ocular systems. This is pesticides getting into your eyes. This is the nervous system. That means that the pesticide has gone actually into your body and you are at this point actually poisoned because your nervous system has started to give out. Then we have gastrointestinal, that's accidental ingestion. Some people have breathed them too much. An awful lot of them, the amount of time lost from work is actually, I thought that was spectacularly low. And then this is the breakdown of how they were done. What this means is our reliance on increased pesticide use is having quite a serious health issue on sort of imported labour. So, thought we'd just go take a second of a fake clicker question. So increased agricultural efficiency has significantly impacted the environment. Which of these is not true? Which of these is not true? I'll say this in the US. So is it A, increased efficiency has increased methane production? Increased efficiency has reduced land allocated to conservation? Increased efficiency has led to increased pesticide use? Increased efficiency has increased oceanic dead zones? Just give you 10 seconds on that to think about what your answer is. Okay. Actually, the answer in this case is increased efficiency has led to increased pesticide use. Remember, early on when we talked about that graph of increased grain yield per hectare, in recent years, one of the big things that's really increased efficiency has been the use of transgenic crops. This use of transgenic crops has meant we've had to rely on less pesticide. So increased efficiency has not increased pesticide use in the US. So now let's have a look at agriculture and future challenges. Because remember, this is, on this graph here, we've got time, we've got human population. The amount of people in this world is going up an awful lot. On this graph, A, this is the point at which we started agriculture about 10,000 years ago, led to an increase in population. B, this is the Roman Empire and the start of civilization. C, this is the bubonic plague, killing everybody in Europe. It's probably a little bit on the nose right now. And D, this is the Industrial Revolution. Then we have this huge increase in population. What that's meant is we've had to change the way we manage our farmland, and we've changed the amount of farmland we require because we have a huge food demand, much higher than it was historically. If we look at how the agricultural lands have changed between 1982 and 2001, we see first of all, this is the total amount of land. Total amount of land has gone up an awful lot, it's more than doubled. And look at where that land has come from. Most of it has been the conversion. We've got an increased use of previously forested land. What that means is increased agriculture and the addition of this land has been driven predominantly by deforestation. This is why you hear about things like the deforestation of the Amazon to convert it into farmland. That is what has driven this massive increase in the amount of acres that we can now farm on. A lot of other things have stayed relatively similar. All right, cropland has increased a bit. Pasture land, that's increased a fair bit. Rangeland, that increased a bit. But the biggest change from 560 up to 1040, more, just about doubling, has been in conversion of forest to agriculture. If you have a look at the change in prime farmland over the same time, we see that cropland had a big increase in the 90s and that's now actually been reduced. Forested land has increased, pasture land went up and then down. So overall, the total amount of land we're using has increased and there's been a change in what that's actually used for. Okay. One of the other things that's become a bit of a future challenge is a switch from farming for food to farming for fuel. So on this figure here, we've got time on the x-axis, and on the y-axis we have percentage share of food for fuel. And we're looking at two different types. We're looking at soybean for biodiesel and corn for ethanol. Only going back as far as 2000, less than 7% of all the corn we produced was actually used for ethanol. The vast majority of it was food. Nowadays, it's up more towards 40%. I don't know if you've noticed, but when you fill your car up at the gas station, There'll often be a little sign on the pump that says up to 10% of this fuel is ethanol. That 10% ethanol comes from corn, so corn production. The reason that we're moving away the reason that they're adding ethanol into fuels now is because it slightly reduces the demand on fossil fuels. So as a result, it means we can potentially stretch out the fossil fuels longer, and there is some argument that it is a bit more sustainable, but not really. In addition, the amount of soybean oil that we use for biodiesel has increased from absolutely nothing in 2000 all the way up to 25% nowadays. The use of soybean oil for biodiesel is kind of crazy. You can actually now run a car entirely off veggie oil, especially used veggie oil. Two friends of mine once decided, this is when I lived in Canada, they decided they were going to drive as far south as they possibly could without spending a penny on fuel. The way they did that is they bought a busted-ass old Mercedes diesel. These cars, the engines on them are so detuned, they will literally run off neat veggie oil. You just put veggie oil straight into the tank. Has to be used, but you can use it. Because restaurants have to pay to get rid of their used vegetable oil, restaurants were only too happy to give these two guys their used oil, because it meant they didn't have to pay to have it taken away. These guys were able to drive from Victoria in British Columbia all the way down to Sayulita in Mexico before they decided they had enough, and they just gave the car to a local surf shop. They drove a car entirely on biodiesel across an entire continent without paying a penny for fuel. So that's why we've had this increase in soybean use for diesel as opposed to food. Also, one of the things that's a big future challenge is looking at the changes in farm income and expenses. So on this graph, on the x-axis we have time, on the y-axis we have billions of dollars. And these three lines represent three different things. The black line is gross farm income. That's the amount of income that just comes into the farm. As you can see, it's ticked along, pretty stationary, and it's a bit of an uptick in recent years. But this line shows production expenses. And production expenses have basically kept pace exactly with farm income. So what this means is, although the farm is generating more money, its expenses are much, much higher. As a consequence, the net farm income, the amount of that money that's actually given to farmers, has actually stayed pretty much the same ever since the 70s. What's therefore happened is, although the farm is potentially generating more money, that money is not going to the farmer, it's instead going to secondary industries for people that are making the machines, people that are supplying fertilizers, people that are supplying pesticides. As a result, we have this challenge where in the future we're going to have to work out, although our farms are becoming more efficient, the economic benefits are not being passed on to the farmers themselves. Also, one of the big things we've talked about a few times is that climate change is going to lead to more droughts in more places. Because of this, we're going to have to worry about what we're going to do with our agriculture and potentially increase the reliance on irrigation. So, let's have a think about some of the sustainability solutions and some of the agricultural practices that can be done to reduce some of the issues that are generated by increased farm efficiency. Well, there's a couple of them. One of the ideas that's become quite popular recently is cover cropping. The idea behind cover cropping is immediately after you harvest your main crop, so for example, immediately after you harvest your field of wheat, rather than just leaving the field fallow and not planting anything, so you harvest in the fall and then you don't seed again the crop that you're in, your main crop, until the spring. That means you leave during the winter, you just leave the field fallow. Nowadays there's a move towards what we call cover cropping. And cover cropping is the planting of some other crop during the winter so that the soil is not exposed to the atmosphere. The idea behind it is the soil therefore doesn't get blown away, and so the cover crops mean that it increases the quality of the habitat for longer. In addition, these cover crops can actually be harvested. So there is a profit bonus now, because cover crop trials lead to a $14 per acre increase in subsequent corn yields, and also the cover crops themselves can be used to harvest biofuels. In addition, there's a move towards no-till landscapes. So no-till means you don't churn the soil. That lack of tilling reduces again the loss of topsoil. And combination of things like no-till, rotations, cover crops boosting organic matter, maximise rainfall, and this helps to break the cycles of weeds and pests and can lead to both increased revenue for the farmer and also reduced loss of topsoil. One of the other things that's a move towards now is what we call coupled livestock crop systems. This can also aid with the cover crops can aid with this because what you do is, rather than just having grassland, or rather that you have for cattle, or rather than just having cropland that you're using to produce vegetables and cereals, you have a mixture of the two. So during the main growing season for arable land, spring to fall, you use the land to produce cereals and other crops. During the winter, you plant cover crops, and then when those cover crops are grown, you then allow farm animals to graze on it. As a result, it's reducing the need for external fertilizer, it's reducing the need to feed cattle grain, and so you get environmental and cost savings. It also means you're actually using your cover crops directly for feed. That means you don't have to spend money harvesting them, and it reduces overall problems with livestock densities. One of the other things that's becoming very popular nowadays again is actually rotational crop systems and diversified crop systems. Rotational crop systems means you have landscapes that look a bit like this. You can see the habitat is divided and each strip has got a different colour. That means it's got different crops growing on it. Rotating crops between years means that different crops take up different nutrients from the landscape. It protects the soil and increases yields overall. Diversified crop systems means you're planting multiple species of plant in the same place at the same time, and that can have the same effect. And the general benefits of these rotational crop systems and diversified crop systems are reduced levels of pests and weeds. It reduces pesticide-herbicide use because not one single pest can come and just eat everything of one crop. It also reduces the need for fertilizer applications, and it gives some economic protection against crop failures. If you lose just one species of your crop because the environmental conditions aren't great for it, that doesn't mean that your entire crop is going to fail. One of the other things that's come along in recent years has been a massive ramp up in the use of technology. So this is happening over here in the US, but especially in places like Australia that have got real serious water problems. They now use drones and automatic sampling inside of tractors that continuously sample the soil and sample the crops themselves and target specific areas where either there's a pest outbreak, so we need an application of pesticides, or if there's areas where the soil just doesn't contain enough nutrients, so we can target where we put fertilizer. Also, we can target exactly where we want to put water so that we're not overwatering in certain areas. This has become heavily mechanized. In many cases, farmers themselves have these machines added to their tractors. This is actually generating other social issues with the right to repair movement. In other cases, they actually hire independent contractors for short amounts of time. We were in a place in Australia, this is a sugarcane plantation, where they actually would hire somebody to come and take their drone out and do targeted pesticide applications into places with pest outbreaks. The benefit to this is overall, you reduce your applications of pesticides, herbicides and fertilizer, and this also leads to overall reduced water use. So it generally has a lot of benefits. One of the other sustainability solutions that's gotten popular in recent years has been urban farming. So urban farming, we get things like community gardens and rooftop gardens. These are great. One of the places in which this really took off, which was kind of crazy, was actually in Detroit after the economic downturn. Following the economic downturn in 2008, many housing lots in Detroit were basically abandoned and burned. Local communities would smash the house to bits and actually turn the plot into a community garden. That way they were able to source food for themselves. Urban farming is kind of cool. I mean, it has a lot of potential benefits. For one, it has reduced pressure on agricultural areas. It also can aid in the reclamation of abandoned and unused lands. This is especially what happened in Detroit. It does reduce transportation costs. If you're not having to bring your agricultural products out from rural areas into the cities. Instead, you're just growing it in the cities themselves. You've got reduced transport. It also has educational employment opportunities. People get to learn about where their crops come from. People get employed as gardeners to look after these places. And it has the potential to improve health of diet. One, people are eating more fruits and vegetables. And two, the vegetables they're eating are a bit fresher. The only thing that's a bit of a concern about this is the air quality in cities is not great generally, and they can have quite high levels of lead and various other carbons. That being in your diet doesn't necessarily strike me as a great idea, but who knows. One of the other things that's happening an awful lot is changes to agricultural policy generally. These are some of the things that have taken place in Europe quite heavily. So in Europe, you can now get specialised crop insurance for diversified farming operations. If rather than just planting one single crop, you opt instead to plant multiple different types of crops, or you do crops and livestock, you can get different insurance policies that are a lot cheaper because the insurance company recognises a diversified operation is generally more resilient. There's also proposed changes to the way that farm subsidies are given, especially subsidy limits. The issue with excessive farm subsidies is it generates an economic situation in which the production of excessive crops actually benefits the farmer, so they're trying to push that away. They're also changing insurance premiums by farm income, and in the UK especially, there's big changes in conservation requirements for subsidies. For example, in the UK now, it is absolutely impossible to get any sort of farm subsidy if you have deforested a piece of land to convert it into agriculture. They will not give you a subsidy for that at all. One of the other things that's happening that you might have even noticed is market changes. So nowadays, we see a lot more farm to school and farm to institution programs. Even here in Logan, they have things like the special farm to plate dinner that takes place down at Herms every couple of months. Then we have farm to school, where rather than schools buying their food for school lunches from a big centralised corporation, they can instead source it directly off local farms. Also, we're seeing a big increase in local markets. So local markets are things like farmers markets, where you go to the market yourself and you buy the food directly off the person that grew it in some cases. And a lot of potential benefits to this. Again, we've got reduced transportation, storage and packaging costs. In many cases, when you're buying food at a farmer's market, there is no packaging at all, especially if you take your own bags. It also supports diversified crop systems, does lead to improved diet. You're often getting better quality food and it's a lot fresher. Again, you get an educational opportunities, especially with the farm to school programs. School children actually get to interact directly with the people that are producing their food. And also what's a big benefit is in many cases, the farmers themselves can sell at retail rather than wholesale prices. That means that much more of the value of the crops they produce is given straight to the farmer rather than to large industrialized corporations. Here, this is really popular. You might have driven across the Utah's famous Fruit Highway, the bit that runs from Perry to Salt Lake. There, they've got a whole bunch of peaches and other things. That season will be kicking off, hopefully, if all goes well, sort of like May, June time. And also, what's happening with this market changes is it's reinvigorating the local farms. Because at these farmers markets, this, for example, is images I actually took at the Cache Valley Gardeners Market. This takes place just by the town hall on Saturday afternoons all the way through the summer. It's really good, the food is great, and it's really cheap. It is fresher food and it's locally grown. All of the food that you see there is sourced from local areas around Cache Valley. It's really fresh and it's good and cheap. However, this whole market sector of farmers markets and local farms only accounts for less than 2% of the overall food market. Generally, the big, huge supermarkets are much, much bigger. It can be more expensive, but it's actually usually not if you know where to shop. The big thing is it cuts out the middleman in the supply chain. One thing that's interesting about here in Utah is that at these gardeners markets and farmers markets, Utah sales tax is not applied. You don't pay any tax on the fruit and vegetables you buy. That then raises a question of, should we really be giving a tax break to something that, let's be honest, is a bit middle class? If you look at the people that are shopping at these gardeners markets, it tends to be people from sort of better well-off socio-economic backgrounds. We're giving them a tax break, even though, well, do they really need it? And what we have to still reconcile with is that even with the rise of these gardeners markets, nationally, very few local farms are profitable exclusively from farming, and they have to diversify. So, for example, an example of that diversification is if you look at Dwight Schrute from The Office. Schrute Farms is technically a beet farm, but they also advertise that it's a great place to hold your wedding and a great party venue. As a result, it's an indication of how local farms are having to diversify. With that respect, I would like to introduce you to our local farm. This is a local farm that my parents still live on to this day. It's called Pygrieve Farm. It's a lovely little idyllic place in rural England. If, however, you look up Pygrieve Farm on the internet, the first thing that comes up is Pygrieve Farm Country Cottages, because this is the main way our local farm makes any money. This is the main farmhouse, and then we have this series of delightful little stone cottages. We rent these out long term, and people stay with us. Some of them moving up for sale right now, but this is how we make our money. Even though we've got pictures of happy little cows, and yes, out the back of here are some lovely Aberdeen Angus. We also have sheep on it as well. The fact is, our farm, its main source of income is rental cottages. We've made far more money out of rental cottages than we've ever made out of livestock, because local farms have to diversify. Okay, just like to end with you thinking about what your spending habits are personally. So, my spending habits with respect to fruit and vegetables. A, I'm on a meal plan, live with my family. I spend none of my own money on groceries. B, I predominantly eat out or eat ready-made meals. C, I purchase fresh produce meat exclusively from large supermarkets, Smith's, Macy's or Walmart. D, I purchase 50% of groceries from the farmers market, local sources when available, 50% from supermarkets. E, I purchase mainly from the farmers market and grow my own. I try to avoid the supermarket. Just think about what your own spending habits are and email me if you're interested. So, one of the last things we really should end on is agricultural sustainability possible? Are we able, as a globe, to actually maintain agricultural sustainability? Well, as a world, we currently produce enough food to feed absolutely everybody on the planet happily. There should be nobody going hungry. However, in our global system at the minute, 25% of food calories and 50% of total food weight actually go unconsumed. What this means is our food waste is so high, that's what's generating world hunger, even though we currently produce enough food to feed everyone. Okay, so that's the end of this class. I will speak to you soon, and have a good one.